So the more of this we put in, the less of this we have. The more of this starts to disappear until eventually they meet and everything has been converted. All these hydrogens have been reacted. That's going to be the neutralization point. So now it's a matter of keeping track of how many moles did we put in down here so that we know, and then we can figure out how many moles must have been present with the hydrogen to start with. Okay. This is what I just said. So, okay, let's take a look. Here's what will help you. You may want to draw this, like sort of make a crude drawing of what we just showed, like with the burette and all that kind of stuff. It may help separate things out if these numbers start and words all start running together on you. But here's what I say. A titration of 10 milliliters of a hydrochloric acid solution of unknown concentration requires 12.54 milliliters of a 0.100 molar sodium hydroxide solution to reach the end point. Don't be discouraged with the wording. Just break it down. What is the concentration of the unknown hydrochloric acid solution? Think about it. Make a plan before you ever start freaking out about the words. If we have a titration, you've got this picture in your head. Okay, you've got some sort of container down here that you're going to be putting something in, and you've got some sort of burette up here. Okay? I can't, whatever. It's not picking it up. Hey, there's no art in chemistry. At least nothing that can't be computer generated. All right, so you got this situation where you've got something that you're titrating, you're bringing down through here, and something else it's landing in. Okay, now the question is, what goes where? The titration of 10 milliliters of HCl solution, titration of, that means it was titrated against, so that means it's going to be down here. But if you can't figure it out from that, then look at this. It says requires this many milliliters of this concentration of sodium hydroxide. That means that if this was required, that's how much you put in, right? That's what was dropped out of here. So you can start labeling this. You know that 12.54 had to go up here with this. So we've got 12.54 milliliters of NaOH of actually 0.100 NaOH. That's this. Then it says what you had in here then was 10 milliliters of HCl. Now, we don't know what the concentration was of that. It tells us what we don't know. So that's what we're obviously trying to solve for. Okay? So the question then is, what is the concentration of the unknown solution? All right. How are we going to start this? Before we do anything, what we need to know is the chemical equation that's going to happen first. Okay? We need to know what is our reaction. When we mix together hydrochloric acid and sodium hydroxide, what is going to be our chemical equation? Okay? Now this one's an easy one. So if you take HCl and NaOH, what do we get? So here we go, salt water, right? All right, balance it because we're going to need that stoichiometry later. Is it balanced already? It's already balanced. Okay, but make sure, always make sure. All right, there's what we need. So we know that in this case it's a 1-to-1 ratio. That's what's going to be very important. All right, so we take a look. We know that we dropped out of here 12.54 milliliters, right? And we know that the definition of molarity is moles per liter, right? Okay, can we get number of moles from this? What we have up there. 12.54 milliliters of a 0.100 molar sodium hydroxide solution. That was what was used. Can I figure out moles from that? I can. Make sure you understand how. Here are 3 variables. If I know 2 of those variables, I can solve for the third one. This is the definition of molarity. It's how many moles you have per liter of something. So I've got 2 of those variables right here. I've got concentration, which is the big M, this part of it, and I've got liters. All I got to do is convert that to liters. So I have moles. Okay, that's very important. I know the number of moles that it took to react all of the hydrochloric acid that was present. So guess what I know about hydrochloric acid? I know how many moles of it I have because it's a 1-to-1 ratio. Now, if it was not a 1-to-1 ratio, you would have to set up stoichiometry. If it was a 1-to-3, you would have to, take times, divide by 3 or times 3 or whatever. Okay? But in this case, it's a 1-to-1 ratio. So however many moles I drop in here is how many moles of hydrochloric acid must have been present. Okay? So now that I know moles of hydrochloric acid, and I know milliliters, what do I know? I know moles. I just figured that from what dropped down here. And I know volume. I can change milliliters to liters very easily. I know the molarity, which is what this is asking. Okay? All right, so let's put the math in there. Let's just skip this because I've already talked about what we're going to. I don't want to confuse you. I don't know. Anybody find these solution maps helpful? Do you? I don't like them, but if they work for you, then use them. It helps you. It helps you sort of abstractly more think about the problem and see where you're going. But other than that, I don't. All right. So what it's saying is, we know how many. If you look at the problem, the way we had it set up, we know how many milliliters of this concentration of sodium hydroxide we used, and if we know concentration and we know milliliters, the concentration of volume, then we know moles, and that's the point of this first line. We can go from milliliters. Okay, we want that in liters because that's what concentration is in. Now, this is one way to do it. To go from liters to moles, you can either just do what I said and realize that big M is equal to moles per liter and solve that way, or you can use it as a conversion factor, moles per liter. Either way, you'll get the same answer. Get it to moles. Whatever you do, get to moles of hydrochloric acid. Okay? Now, once we know moles of hydrochloric acid down in the bottom, then all we need to know is take our moles, take our volume that we started with, and we can end up with molarity. Okay? So this is the math for all of that. Okay? I'll leave that with you. I've already explained it all. You can go through and trace the numbers yourself. So final answer is our mole value that was used was this. Okay, 1.25 times 10 to the minus 3. How does that play out in solution? Well, we've got to realize that moles per liter. We used 10 milliliters of HCl, right, in the bottom. So that's this in that's this. I converted to liters. So we take our moles divided by our liters to get our concentration. We figured out that the concentration of that acid was 0.125 molar. That's a pretty involved problem. It requires a lot of knowledge. It requires you to know chemical equations, be able to predict products, be able to use stoichiometry, be able to understand what acids and bases are, be able to use conversions, basically do everything that we've learned so far. Okay? Yeah. No. No, it's going to be all spread out over everything. Right. You're right. You're right, but to be fair, what I could do is just basically ask you things from the last 3 chapters and then know whether or not you've studied everything else, because it's all. But to be fair, just to be a little nicer, I pull some just basic questions from the very beginning stuff, like sig figs and that kind of stuff, so that some people could get some points on the test. Otherwise, I may just bomb everything. So. But in all actuality, you're right. I mean, I should be able to ask like this question, and if you don't understand atoms, you don't understand the periodic table, and you don't understand charges, how to name things, how to write equations, then you can't do this problem, as some of you have just figured out, right? But like I said, I'll throw in I'll toss some watermelons every once in a while that you can swing at, as opposed to just fastballs, curveballs, and all the like. Okay, all right. Boost your confidence a little bit as you're taking the test, huh? Yeah, and that's the hard part. I understand that. I mean, I've been there too. I know that I could sit through lecture and watch a guy fill up a board all the way around the room and follow it, but the second I leave the door, I have no idea what's going on.
So how do we combat that?
Study. I mean, I don't know. I mean, all I did was studied and studied some more, and eventually learning gets easier. I know that's not the best news you wanted to hear, but yeah, I mean, the homework problems are designed to help you on the test. So, I mean, those are the key. Yeah.